Okay, a body of mass m is broken into three parts. Let's say body of mass m, it is broken into three parts. Two parts have the same mass. So let's say our body has mass m. So mass of one particle is m dash and another particle is also m dash. And mass of the third particle is 3 times of m dash. So m dash plus m dash plus 3 times of m dash equals to m implies m equals to m dash equals to m by 5. So this body is exploded into three masses. So m dash is moving with velocity 12 meter per second, and another mass of m dash is moving with 12 meter per second perpendicular to it. What should be the velocity of third particle, that is 3m dash, such that the entire momentum will be 0? So by applying conservation of a linear momentum, we can say that entire momentum should be 0. So velocity of 3m dash should be in such a way that entire momentum will get to be 0. So let's say it's v double dash. So let this be the coordinate. So this is 12 meter per second. This is 12 meter per second. This is v dash. This is v1. This is v1. And let's call it v dash. So v1 bar m dash plus v1 bar plus m dash plus, let's call it v2, m dash into v2 bar plus 3m dash into v dash bar is equals to 0. So 3v dash bar is equals to minus of v1 bar plus v2 bar. This implies, okay, let's call it as I cap, positive I cap in this direction and positive j cap in this direction. Then 3v dash bar is equals to minus of minus 12 I cap plus 12 j cap. This is equals to 12 times I minus j v dash bar equals to, it is 4 times I cap minus j cap. So whose modulus is equals to 4 root 2. So magnitude of velocity is, magnitude of velocity is 4 root 2 and its actual velocity is 4 I cap minus j cap, where j cap is the direction of velocity of one object and minus I cap is the velocity of direction of second object. So this will be the velocity of the mass particle of mass with 3m dash.